Hi students, this is Dr. Davis again doing a video for you for Unit 7 this time. We're talking about graphing. And with graphing comes a lot of things, such as the coordinate grid. What quadrants do we need? How many quadrants are there? And why do we need coordinates in the first place? Not to mention slope, functions, what does it look like when we graph each individual point? That's what we're going to be talking about today. So, for this particular exercise, it's just basically plotting each point on the graph. Remember, in order to plot on a graph or on a coordinate grid, you have to start at the origin, which is at 0, 0, and either go left or right on the graph in order to get the x value, and go up or down to get the y value, okay? A quadrant. Let me show you a picture of a quadrant. This is what it looks like. Because when you think about quadrants, you can't just graph any old line. You have to know what quadrant it fits in. So let's talk about quadrants first. I'll show you a picture. I didn't have it up just a moment ago, but I just wanted to show you a picture of what the quadrant looks like in a coordinate plane, just so that we're clear and so we know what we're looking at. And when it's time for us to graph, we know exactly what to graph and how to graph it. All right, here's a perfect example. The quadrants are in counterclockwise motion. So the way the clock runs, not that way. It's the opposite way. So here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Quadrant 1, as you can see, has all positive numbers. Positive x's, positive y's. Quadrant 2 has negative x's and positive y's. Quadrant 3 has negative x's and negative y's. And quadrant 4 has positive x's, and negative y's. So that's just a brief intro of what quadrants are, okay? So for the exercise we were just looking at, we're just going to be working in quadrant 1. All right, plotting points. Let's talk about it. For T, where is 3, 3? Starting at the origin. At 0, we go over to 3 because 3 is positive. So we go over to 3 and we go up to 3. And we make a little dot right here. Okay. Number 2, S is 1/8. Here's 1. Starting at 0, here's 1. And 8 is all the way up here. 1/8. Okay. Number 3 for 8, 2/8. Starting at 0, go over to 2. Go up to 8. That's 2/8. Number 4, 6, 2. Starting at the origin, go over to 6. Go over to 6. Go up to 2. Go over to 6. Go up to 2. That is where number 4 is. For number 5, 5, 4. Start at 0. Go all the way over to 5. Go all the way over to 5. And then go up to 4. Okay. For number 6, 7, 6, start at 0. Go all the way over to 7. Go all the way up to 6. That is 7, 6. Okay. 3, 1. Start at 0. That's number 7. Start at 0. Go over to 3. Go up to 1. Number 8, 9, 5. Starting at the origin. Go over to 9. Go up to 5. Okay. Number 9, 7, 1. Starting at 0. Go all the way over to 7. Go up to 1. At number 10, 4, 7. Starting at 0. Go over to 4. Go up to 7. Okay. That's your review on how to plot points. Okay. Let's go to the bottom. It says draw a circle at 3, 1. We're just going to put our mouse there. At 3, 1, starting at 0. Starting at 0, going over to 3 and up to 1. Going over to 3 and up to 1. So you put a circle right here. Circle would go here. It says draw a star for number 12 at 4, 5. Starting at 0. Here's 4. And going all the way up to 5. So at 4, 5, we put a star there. Okay. Put a rectangle at 1, 7. So at 0, go over to 1. go up to 7, put a rectangle there. Okay. Draw a triangle at 3, 4, starting at 0. Go over to 3, go up to 5. So at 3, 5, you have a triangle. For number 15, where it says 8, 2, starting at the origin, go over to 8, go up 2. So a square would be there. Okay? Just a brief overview of what we just done. We just did the quadrant, the review of the quadrant. Quadrant 1, 2, 3, and 4 in counterclockwise motion. We also did plotting of points based on coordinate pairs. These are coordinate pairs. So we did the plotting of letters. And we also did, in a small part, plotting of shapes. Okay? So any questions or concerns on what the coordinate grid is, what are coordinate pairs, how do we graph, any questions or concerns that you have on this video at all, please either email me or put it in my inbox and I'll send you a quick response, because I want to make sure that everybody's on the same page as we're going through this section, because if we're all on the same page, we can start together and we can finish together. Okay? Now, let's talk about the next item of business. Talking about ordered pairs as it relates to vegetables. As it relates to vegetables. Okay? It says write the ordered pair for each item. So how about we do this? How about we look, let's see if I can decrease it. There we go. Let's make it just a little bit more small. Okay? Let's go through and decide what coordinate pair is here. And feel free to go ahead with me if you like. This looks like an eggplant to me. So starting at 0, going to 1, and all the way up to 10, the eggplant is at 1, 2. Okay? And I'm going to take it one row by row. For the tomato, starting at the origin, going over to 2, going up to 2. So 2, 2 is the tomato. Okay? I see a watermelon up there. Starting at 0, going over to 2. Where the watermelon lands is 7. So 2, 7 would be the coordinate pair for the watermelon. This looks like either a beet or a radish. So, whichever one it is, I'm going to start at 0, go over to 3, go all the way up to 4. So 3, 4 is this radish type beet thing. Okay? For 4, it looks like that's an apple. So starting at 0, going over to 4, going up to 9. So at 4, 9 is an apple. Then we have pineapple. Starting at 0, going over to 5, going up to 2. So 5, 2 is your pineapple. 5, 2. Then we have a pumpkin. So starting at 0, going over to 5, going all the way up to 6 is a pumpkin. Okay? Next, we have a strawberry. Starting at 0, going over to 6, going all the way up to 8. So 6, 8 is a strawberry. Now, I don't know what this is, but we're going to call it a fruit. So starting at 0, going all the way over to 7, and going up to 3. So 7, 3 is this fruit. Okay? This looks similar to an onion. So for today, it'll be an onion. So at 0, going all the way over to 8, and up to 1, 8, 1 is this onion-looking thing. And then this is a pepper. I'm going to call it a jalapeno pepper. So starting at 0, going over to 8, going up to 9 is a jalapeno pepper. 8, 9, 8, 9. Then we have broccoli. Starting at 0, going over to 9, going up to 5 is a broccoli. So 9, 5 is a broccoli. Then this looks like a pear. So starting at 0, going over to 9, and going up to 7 is this pear-like shape. Okay? Any questions on ordered pairs before we move on? Questions? 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 Okay? All right. Let's cover what is a function. What is a function? A function, talking about the line test. So a function, for example, a straight line. A straight line is a function if I can only have one touching point. One touching point. For example, here's a straight line going all the way out here. If I'm to draw a line here, it only touches this particular line one time. One time. Okay? Same thing here. For this function, based on the way it's drawn, when I draw a line here, I can draw a line here. It only touches the graph one time. However, in terms of this particular function, if I were to turn it the other direction and drew a straight line down through it, it has 2 points touching the line. This is not a function. This is not a function, okay? Even if it were a circle, if I were to draw a line here, even the origin here and here, I still have at most 2 points touching the line. That is not a function, okay? So in order for it to be a function, it cannot have more than one touching point. Okay? If it has more than one, it fails the line test. Okay? I just want to go through functions because that's the main gist of functions. What is a function? It's a line or a graph that when a straight line is drawn through it, it can only touch it at one point. When is it not a function? When there's, for example, a circle, a parabola, where a line is drawn through a parabola, it has 2 touching points. That's not a function. For a circle, as you can see here, it has 2 touching points. That is not a function as well. Okay? All right, let's keep going. Let's talk about slope. This section talks about slope. So I'm going to need to bring up an additional Word document because I want to write this out for you in terms of slope. What do we need? What formula do we use for slope? Why do we need slope? I'll tell you. We need slope because we need to know the rate of rise over run in our particular situation. And if we don't know that, it's going to take us forever to find out. Now granted, there are ways to find out quicker online, but I've always told my students, please do not rely on online calculators or digital calculators that can give you the answer instantly, because of course when you take your exam, you won't have those tools. So it's better for you to get used to doing it by hand, and that way you know exactly what answer you have before you submit it to me. Oftentimes a lot of students are like, I didn't know I could check my answer. Sure you can. However, you have to ensure that when you check your answer, that you've taken the time to make sure that it is correct. Check your answer once, twice, maybe even 3 times if you need to. However, you have to make sure that when you check your answer, you know it's correct. And then when you submit it to me, you should already know that your problems are correct before you submit it. If you are unsure, you can send me an email. However, I cannot give assistance on assignments that are submitted for a grade. I just want to be very, very clear on that because it will give you an unfair advantage. And I don't want to give anyone an unfair advantage over anyone else. So the best idea that I have is that you take your time, you go through the exam. As our next exam is approaching, take your time, go through the exam, make sure you know what you need to know forward. If you do not know, then we need to either have a big blue button conference or an email discussion or phone conversation, because I want to make sure that you have everything you need in order to be successful for this exam. All right. Sorry for the delay. My Microsoft Word is working very slow. I want to write out this formula for you because I don't want you to think that you can just automatically pick a number and that's slow. There is a formula for this. So in this formula, while it's some time to upload, The formula is y2 minus y1 over x2 minus x1. Give it just a second to pop up. Again, I'm having technical difficulties with my Word document, but nonetheless, we move on. But with this formula, once you have this formula and you're able to do labeling, which I recommend, labeling is the best way to do these kind of problems because it gets it out of the way quicker. All right. Here we are. All right, let's talk about the slope formula. Try not to make it too big. All right, let's go back here. Let me show you what the slope formula looks like. Because by the time I write it out, it may look just a tad different because it's in a Word document. What is the slope formula? Some of you have seen it before. The slope formula, since the computer is acting just a tad slow, y2 minus y1 and that's divided by x2 minus x1. Okay, now let's go back. Here's a formula. Took a little time to come up, but this is a formula. M equals y2 minus y1 over x2 minus x1. There it is. Okay. So let's start looking at some individual problems. All right, in these situations where you have, for example, a line, you can't even see the points. You have to determine the points for yourself. Based on how we just did the graphing, you have to start at the origin, which is here. Go over 1, that's actually -1. Go down 1, that's -1. Okay? So we have -1, -1. Here is another point, starting at the origin. Going over 1, 2 points, down 2. So you have 2 times 2. Okay. Now, let me label. This is x1. x1 corresponds with -1. This is y1. This is the first x coordinate. This is the first y coordinate. Now, this is the second x coordinate. This is the second y coordinate. Okay? So now we have everything labeled. We got x1, we got y1, we got x2 and y2. So that's when we come up here and we put the coordinates in place as we have them labeled. y2 is 2. 2 minus a -1. 2 minus a -1. Okay? Draw a line underneath it. x2 minus x1. 2 minus -1. 2 minus -1. Well, 2 negatives make a positive here and a positive here. So we end up with 3 over 3. 3 over 3 is the same as just 1. Okay? So once you get your coordinate pairs, label them and go ahead and plug them into the equation. If you can do that, that will deduct a whole lot of time. All right, let's do number 3. Trying to do problems that fit on this side of the screen so that way I can keep this section open here. Okay. So now we have this point and this point. Let's see, starting at 0, -1, -2, -3, -4. This is -4, 0. And then the next point is right here, starting at 0, going over 1, 2. That's -1 and -2, going down 1, 2, 3. So we're at -2, -3. Okay. All right. So y2 in this case is -3. y1 is 0, -3 minus 0. x2 minus x1, x2 is -2, minus x1 is -4. -3 minus 0 is the same as -3. So I'll underline underneath it. Here, two negatives make a positive. So you have -2 plus 4. That's the same as 2. So your final answer will be -3 over 2. Any questions or concerns on this material so far? Just want to make sure we're on the same pathway. And of course, these type of worksheets are available online anytime. All I did was I typed in slope worksheet because I wanted to work through these problems with you. I wanted to make sure you had everything you needed to be successful in completing this week's practice homework as well as your Dropbox homework. Again, for the Dropbox homework, only submit the Dropbox homework. Your practice homework is just for your reference. All right, let's keep moving. Here is a website. It's called webmath.com/gpoints.html. Oftentimes, sometimes you may or may not know, hey, am I typing this right? Hey, am I doing this correct? So, let's look at these points. For example, 1, 1, and 3, 4. And, for example, 1, 1, and 3, 4, you try to draw them by yourself first. Then you click Draw Them. When you click Draw Them, it plots 1, 1, and it plots 3, 4, so that way you can see exactly where it is located. Okay, I just wanted to show you that tool because I think that oftentimes we may not be sure on how to graph, and I think it's better when you try it on your own first and then look at this graphing element to see if you did it correctly. Okay, so I just wanted to make sure you saw that because that's another way to look at mathematics problems in a digital format. All right, next, how do you graph points with just intersects? And I'm going to try to get this in here because I don't want the video to run out before I'm able to do this. So, let me erase all of this. 4x plus 5y equals 20. And I'm going to write this out as detailed as possible. In order to find the y-intercept, substitute a a 0 for, come on mouse, where'd you go? Substitute a 0 for x to get the x-intercept. Substitute a 0 for y. Okay? So let's work on the y first. So we're going to put in a 0 for x, so we have 4 times 0 plus 5y equals 20. Well, 4 times 0 is just 0. So we can get rid of that and just say 5y equals 20. And if 5y equals 20, and we divide everything by 5, you would get y equals 4. Okay, and that's just one. Now and that's for the y-intercept. For the x-intercept, you substitute a 0 in for y. So we have 4x plus 5 times 0 equals 20. Well, 5 times 0 is just 0, so you only have 4x equals 20. If 4x equals 20, and we divide everything by 4, you would get x equals 5. Now, let's talk about y equals 4 and x equals 5. Y equals 4 in coordinate pair form, since we put in a 0 for x, our coordinate pair starts out at 0, put a comma there, and ends at 4. For x is 5, we start at 5, and remember we put in a 0 for y for the x-intercept, so we now have 5, 0. Okay, so we have 0, 4, and 5, 0. So 0, 4 is here. So you put a point right here, and 5, 0 is here, and you draw the line, and there's your line. So 0, 4 is here, and 5, 0 is here. There's your line. Okay? Just want to make sure I had a little chance to get a problem in there. I think I got enough time to do one more. All right. Let me erase this part. All right, 2x minus y equals negative 4. All right, for the y-intercept, insert a 0 for x. So we have 2 times 0 minus y equals negative 4. 2 times 0 is just 0. So you now have negative y equals negative 4. If I divide everything by negative 1, divide by negative 1 here, and here 2 negatives make a positive. So y equals 4. In coordinate pair form, it's 0, 4. For the x-intercept, we put in a 0 for y, so we have 2x minus 0 equals negative 4. And then 2x minus 0 is just 2x. That equals negative 4. Divide everything by 2, then x equals negative 2. In coordinate pair form, it's negative 2, 0. So 0, 4 is right here. Negative 2, 0 is here. So your line would be from here to here, from 0, 4 to negative 2, 0. All right, that's a brief overview of what we have covered so far. I just want to talk about it real quick. We talked about plotting points and what it meant to plot points on a coordinate grid. We only graphed in quadrant 1 for this particular exercise. And we plotted each coordinate pair by starting at the origin and going either up, down, either to the right or to the left, based on whether we're talking about negatives or positives. For this exercise, we only needed quadrant 1 because we noticed all of our coordinate values are positive. Then, of course, here we talked about the fruit, and we looked at each fruit item or vegetable item, and we found out each ordered pair for the items. Then we went on and we did slope. We looked at slope in terms of these particular problems, and we said, oh, we have a line. Now we have to determine what point there is. And with those 2 points, we can find a slope based on the formula m equals y2 minus y1 and divided by x2 minus x1. That is a slope formula. So we use that in order to determine the slope. Then we looked at individual points and how to graph them. And based on this website, we can put in individual points and it will draw them for us. From this worksheet, we talked about graphing based on x and y intercepts. We also discussed what is a function and what is not a function. All right, so far that's it for Unit 7. If you have any questions, feel free to email me. Also feel free to inbox me. If you have any concerns, also please make sure that your homework is in just your Dropbox homework by 11:59 p.m. Sunday. Questions or concerns, feel free to let me know. I'm here to ensure your success in this course.